Hey guys, welcome back. Now let's get started with our day 20 walkthrough. You guys can go ahead and read the story here. So coming to the learning objectives, in today's task, you will learn about Poison pipeline execution, understand how to secure CI/CD pipelines, get an introduction to secure software development cycles and DevSecOps, learn about CI/CD best practices. GitLab and SDLC concepts. GitLab is a platform that enables collaboration and automation throughout the software development lifecycle, which is the framework structure that describes the stages that code goes through, from design and development to deployment. GitLab is built around Git, a distributed version control system, where code is managed. Here are the key components of GitLab: version control system, CI/CD pipelines, and security scanning. Here CI/CD stands for continuous integration and continuous deployment. Continuous integration. Continuous integration refers to integrating the code changes from multiple contributors into a shared repository. In GitLab, CI allows developers and engineers to commit code frequently, triggering automations that leads to the build and test. This is what CI is all about, ensuring that the code changes and the updates are continuously validated, which reduces the likelihood of vulnerabilities when introducing security scans and tests as a part of validation process. Continuous deployment. CD automates code deployment to different environments. During SDLC, code travels to environments like sandbox and staging, where the tests and validations are performed before they go into production environment. The production environment is where the final version of the app or service lives, which is what we as users tend to see. CD pipeline ensures that the code is securely deployed consistently as a part of DevSecOps. Integrating security checks before deployment to production is key. DevSecOps. We have mentioned that integrating security into CI/CD ensures consistency and threat reduction when integrating into the SDLC. This is what the DevSecOps aims to achieve. Everything we have seen so far is a part of cultural and technical approach that aims to improve the collaboration, automation, and CI/CD. It's what we call developer operations or DevOps for short. DevSecOps was born from DevOps and is an extension specializing in security for DevOps practices. CI/CD attacks. This type of attack involves compromising a component or stage in the SDLC. For this attack to work, it takes advantage of the trust boundaries established within the supply chain, which is extremely common in CI/CD where automation is everywhere. When an attacker has access to the version control systems and can manipulate the build process by injecting malicious code into the pipeline, they don't need access to the build environment. This is where the poison pipelines come into play. It's crucial to have effective, secure gates and guardrails to prevent malicious code from getting far if there is an account compromise. Now let's go ahead and fire up a machine. So now we have a login page. Let's enter the username and password. So here we can see a project. Let's go into it. So here the configuration file is written in YAML format. For the GitLab CI/CD, it defines a series of jobs and stages that will be executed automatically when the code changes are pushed to the admin calendar BFC repository. Let's break down what it does. So let's open this. Workflow describes a CI/CD workflow for the value assigned to the commit branch. Install dependency stage. If the pipeline is triggered on any branch, it installs the dependencies if there are any. In this case, it echoes the message indicating the installation step. The before script stage checks for existing Docker container with a specific name, stops and removes if found. This way, whenever a new job runs, there won't be any clashes with the previously running containers. Test stage. Executes in the test stage of the pipeline, runs a Docker container named affectionate Saha based on the HTTPD latest image. Binds a volume from the local directory to the container's web server directory, maps port 9080 on host to port 80 on the container. Artifacts specifies the contents of the public directory. Rules. The test stage runs only if the pipeline is triggered on the main branch. So here in the script we can see some shell commands, whoami, pwd, ls, and here we are running the Docker container. Detective Frost2 received reports that the advent calendar site has been stuck in a testing phase for weeks. However, the team is acting strangely, and the site has been acting up. As a DevSecOps engineer, you must help Detective Frost2 to understand what's happening. We can start by checking if there is any merge requests or items. Merge requests appear when someone has a new code or an updated project version and wants to update the code base with new changes. In other words, they want to merge it. Let's take a look on the merge request. Click on the merge request tab on the left hand drop down. Changes can be seen on the merge tab. So as we can see here, there are no open merge requests. There is one that has already been merged. Let's open it up. So here we can see a discussion between the team. So here we can see that Delph lead is trusting Frostlings and giving him admin permissions for a few hours. So now we can see all the jobs that are run. Now let's check the first one, which is the most recent. Here we can see that it is using port 9081. Now let's try to access that. So here we have Frostlings rule. The page has been defaced. So coming to the questions here, what is the handle of the developer responsible for the merge changes? Okay, so now let's go and check it out. So here this is the commit. So here this change has been made by Frostlings. What port is the defaced calendar site server running on? So we just accessed it. So it's 9081. What server is the malicious server running on? Okay, let's go and check it out. So here it says Apache. What message did the Frostlings leave on the defaced site? Okay, so this should be the message. What is the commit ID of the original code for the admin calendar site? So now let's have a look at the commits. So here we can see that it has similar code and it does not have the access scripts showing the defaced website. So this should be it. Now let's find the ID. Now let's go back. Let's copy this ID. So now we have successfully completed our day 20 walkthrough. Thank you for watching my video and stay tuned for more.